When we talk about Lone Star 6, that's the actual physical thing there.
So I have released the block, so you guys can use the development version by just typing alignEM-dev, which I think Ashley has tried a couple weeks ago, tested that out, and that works for her. So you guys should be able to log on to TAC, start an interactive session, and just type alignEM-dev at the command line, no spaces, no hyphen or anything, lowercase. And that should launch the development version. If you have any issues, then one thing you can try is to type alignEM-dev space -f, and then that will force reinstall Miniconda and recreate the environment. So,
and does that need to be done from TAC? It needs to be done at TAC, right?
Yes, of course.
Well, you can do it from the command line if you're
At TAC. Right, not on your laptop. Right, we're talking about on TAC.
You could do it from your laptop if you SSH though.
Sure, but on TAC. But you've SSH to TAC.
Okay,
right,
gotcha. Yeah. So, and if anybody wants to log in and get a session right now and test that out, feel free. So I just have a few slides and then we'll do a demo. Yeah. Okay. So over the last few months, basically since last time I was in Austin, is when I solidified the stable version that's been being used, that we've been meeting each week with users to discuss with them any issues they might be having. And then, yeah, I don't.
It was putting a line through his text there. I don't know why. There,
so
that's better. Okay.
So the version for the last few months, I think since about the end of June, that you guys have been using, that's all, that hasn't changed a whole lot. I might have pushed a few bug fixes here and there, but for the most part, that has been static. So this version of the application has some serious redesign. A lot of things work a lot better. For the most part, you should feel right at home, like you know how to use it. I don't think there's anything that's like conceptually too much different. Well, there's a few things that are different, so we'll discuss that. So on this slide here, I guess just to start at the top. So the time required to create a new alignment, so that could have been worded better, but what I mean to say is to start a new project, the time to get going on a new alignment project. It used to be in the other version. We'll just call these versions 48, the one that you guys have been using, and 50, the one that's going out today. It's easier with the numbers. So with version 48, like the workflow, it was to import some images. They would get scaled, converted to ZAR, and this would be all part of your alignment project. And that was a single directory that you specify like where to save it to, and then all of like the source images and the converted source images and so on are all in that folder, but also all of your alignment data is in that folder. So one of the biggest changes with this version of the application is that it's separated the concepts of a series and an alignment. So when you import some images, those are going to get scaled, converted to ZAR, do everything it's got to do, and also like write a little metadata file that has some information about the series, and then that can be put on the file server. And then anybody can access that and do their own alignment of that series. So this not only helps with like a sharing of a series, but it also prevents people from having to constantly do that those initial tasks of downsampling the series and converting and everything. That just only has to be done once. One person does it once, and then anybody else can access it as long as they know where to put it, or they know where it was put on the file system. And then separate from that, so when you create a new alignment, the reason it says here that it takes less than 3 seconds with an asterisk is because that's assuming that somebody has imported the series already, uploaded it. Like I think of it more of like an upload. You put the images onto TAC, and then you open up alignEM-SWiFT, and then you create a series, which we'll demonstrate. Right? But the asterisk is because it's less than 3 seconds once that's already done. And then to create a new alignment, you just go new alignment, and then like, where do you want to save it to? And you're now aligning that series. And what's created at that moment is a directory with like a project data file that has all the alignment data and everything. And then the generated images, the generated transformed images are going to go into that folder. But it starts out as just a directory with some files in it, like an empty directory structure. So it's a lightweight. So one thing I want to emphasize today is that portability is now a thing. It used to be that we had these massive alignEM-SWiFT projects, and they were difficult to move around. But now an alignment is a very lightweight thing, because it doesn't have all the source images in it. So the space complexity, which is a good segue, the space complexity is now linear of a project, but not because of what I just said. The reason it's linear is because of what it says for bullet point number 2 there on the right, in the right column. So the major multiprocessing steps in alignEM-SWiFT are there's 3 of them, or there was 3 of them. The first one is to use SWIM to compute the alignment or the offsets of, it will compute the alignment, and then the affine is composed using mirror. So that all happens kind of at the same time. And that takes a set amount of time. And the next multiprocessing thing that has to happen is to apply that affine to some images to generate an aligned result. And then the third thing is to copy convert the transformed TIFF image to a ZAR format. And those all take roughly like the same amount of time, but the most painful one was always converting to ZAR. So now we've completely got rid of step 3 by we don't always copy convert to ZAR. We only do that when you want to. And the reason that works is because something else that I'm going to get to, which we'll get to. And then so we don't do that every time. And when I say every time, I mean anything in the interface when you're aligning, whether you're aligning one or aligning all, or aligning some, or doing a fix all, which is a feature that is a warning is generated sometimes where you can go fix all, and that will just fix everything. That will fix everything in the sense that it's smart enough to know what needs to still be aligned and what needs to still be generated, because those might not necessarily be the same list of indexes. So we've gotten rid of the third multiprocessing step by just making that a thing that you do later. You later generate the ZAR. And then the second one here is really why this has become a linear time thing, because the way the application now works is I will hopefully be able to convince you guys that this is the best thing, is that we have reduced size images. What we used to do is, like, whatever scale you're working at, you would apply the affine to that scale. So once you get to scale 1, you apply the affine to the original source images at that point. and then that produces a transformed image as an output. But now when you get to scale 1, and or any other scale that you're at, we apply the affine to downsampled images. So this saves the compute expense of having to open these large files and apply this affine to them and then write it back to the file system. Right, because we're always doing this to reduce size images, and not only that, but this makes this like a linear thing, because no matter which scale you're at, you're always applying an affine to downsampled images, and you can do that because that works. You just have to scale the translation terms of the affine matrix, so the application does that, and then it produces these transformed images, even though, and key to this is that SWiM is still aligning using the higher resolution images, or whatever resolution you're at. SWiM still uses that, which is the step 1. Whoops. But all that's generated is this downsampled a downsampled transformed image. So this makes everything a lot faster. And another thing that makes things faster is it used to be that you could align all, and like if you kept pressing align all, it used to in version 48, that would always be doing the same thing. So it would always do an align all exactly like it says,
starting from scratch.
Yeah. So now I've created this is called memoization, where you cache the results of a time-consuming function, and so you can retrieve it later. You can check the lookup table, see if you already know the answer, and then just return the answer from the lookup table, and that's a really fast operation because it's a constant. It's just a very fast things. Well, you're skipping all the multiprocessing. So we do that now. And so the point I was going to make about it used to, in version 48, if you keep pressing align all, starting from scratch, it's gonna align all. But now it's gonna hit the cache. It's gonna check the lookup table for each alignment pair, and it's gonna already have the answer. So it's just gonna go done.
I mean, if it already has the answer,
if it already has,
it will use it.
So if you've done an align all and you haven't changed any configuration, and so because I'm caching the result being the affine, that's what we're trying to get out of SWiM. So we cache that, and then not only do we cache the results of the alignments, we also cache everything that goes along with that, which is the match signals, the spots, the matches, which are basically the SWiM region that was being used to align, adjust, like, so it's two. Okay, so for a 2x2 grid, SWiM grid, that's gonna produce 8 match images, we call them, 1 for each region on each image, so 8, right? And so that's total of 12 now little images, and we also scale those and crop them to keep them small. We crop the match signals and scale the matches, all using ART's programs as iScale 2. So that's 12 small files. Then we also create a thumbnail of the aligned result, 13. And then we also, which I'll show you how cool this is, but we also create a little alignment GIF, animated GIF of the alignment, like the flicker. So
the blink image.
So we've got something like 15 small files for each alignment pair each time you align. So not only do I cache the results of the alignment, I also cache all those small files. And I do that using like a hierarchical directory structure that's keyed by the same key of the hash table. And this whole mechanism works really well. and is what I've been working on over the last few months to have this all like implemented. And I wanted to mention that users, I haven't really needed users to make these do this refactoring. I haven't. That's why I haven't maybe as much as I used to be needing user input on the changes, because what I'm changing is really just the internal mechanics of alignEM-SWiFT, and that's done now. And I'm very glad that that's done. It's like what's changed is the project. The data model is completely different, and the project structure is completely different, and like redesigned. And then we cache those small images, and then okay, so the alignment drift problem. What I mean by that is you guys will be familiar with those of you who have used alignEM-SWiFT know that what often happens is, due to the cumulative affine, if you've got anywhere in the stack just a banged up image, whatever, it's maybe whatever might throw off an alignment, and then like the error in the alignment, it gets magnified over the course of the stack. So by the time you get to the end of the stack, you have like, you might just be looking at like a gray thing. It might have gone off like out of the coordinate system of the stack even. And because that's just like a runaway drift thing that can happen. So a really key insight that like I had was we can see how good an alignment is without applying the cumulative, like with just using the affine, not the cumulative affine. So just the pairwise alignment between two images. If you compare the results, like, so you compare the transformed image that results from applying the affine, not the cumulative affine, and you flicker that. If you flicker that instead, that tells you the same thing as comparing. So this is comparing the transformed result of an image after having the affine applied to it, and then flickering that against its reference image, so the one that it was aligned against. And that's just as revealing of how good that alignment is. And this makes it so that each alignment pair, as you're trying to optimize your alignments at each index, and you're looking at your SNR values, since we're just comparing the results of an image to its neighbor image or its reference image, there's not this runaway drift effect. And you would only see the runaway drift effect looping back around to the fact that we now generate the ZAR at the end. So the ZAR is a 3D representation of your alignment with the cumulative affine applied, and that's when you see the effects of the cumulative affine. And you can change the settings associated with that. The two settings associated with that are the bounding box and the polynomial bias, which is a value from 0 to 4.
So Joel, can I just ask a quick question here to be sure I understand what you're saying?
Yes.
So my understanding originally for having the cumulative adjustment is to minimize the amount of overall local distortion that's being done to make the alignment work. But by applying it as you go, a pair gets too much noise from multiple alignments before it that had errors in them. Is that right? So now what you do is you apply it when you've gotten the perfect pairwise alignment across the whole thing. And the SNR graph that you're going to get out is going to be literally a pairwise SNR. It's not going to be a cumulative SNR, correct?
Well, the SNR has always been pairwise only.
Oh, I see. Okay.
Yeah. So that that graph will give you the important information you need to know.
To know which ones to go and fix.
Exactly.
And it still will. But so I'm still just trying to understand what you're correcting for by waiting till the end to do the cumulative.
Where, to jump in here just for a second. Thanks, Joel. What we were doing before was always using the cumulative to show you where you were. But if you have runaway, when you when you initially do your alignment, you're going to have errors in alignment that you haven't yet corrected for. And this then, gets in the way of looking at images later in the stack because the cumulative errors have made it so that the result of applying that cumulative affine to the images puts it outside the frame of the image, right? And I don't know why I couldn't see the solution to the problem that Joel came up with on his own, which was, let's just show the pairwise and don't worry about the cumulative until you're all done. And I think that was a brilliant insight on Joel's part to see that. So in a way, it's kind of like slipping in a little mini version of Protocol 2 into into the tool now. And what's going to happen later when we introduce Protocol 2, that part of it will actually stay the same. And all that will change is how we proceed with the other steps in the alignment.
The elasticity and the triangulation.
Yeah, exactly.
And the montaging and things of that nature. So you're showing us something now here, Joel. Tell me about that.
Yeah, so this is what it looks like. So what we used to use is we would be comparing the aligned result with the cumulative affine.
I see.
But there's so many benefits to this, like such as the fact that what we used to be comparing is the aligned result with the cumulative applied, and comparing that against the aligned result with the cumulative applied of that image's reference. Right. But what's the problem with that? It's that you've got dependency between.
Got it. You're brilliant. I get it. This is what, frankly, this is what I thought you were doing. Based on how we've always done it in Reconstruct. But this is great now that this is in here. But I've always liked the idea of later applying something to the whole volume to minimize the drift, or to minimize the fisheye, or to minimize.
And that's Tom's brilliant code that he's figured this all out how to do that, which is what the cumulative is.
Yeah. So that's what we have with the polynomial bias correction and the bounding rectangle steps, and those you would do at the very end.
I see. So right now, you don't have that bounding box on it while you're doing it. You just have the pair.
Right.
You let the pair have the whole digital space. Space.
Yep.
Got it. Beautiful.
Okay.
Totally get it.
Now another thing I want to point out is that
it's different too. I mean, the degree of squishiness is different.
Yeah, you're not comparing to another aligned image that was aligned to an entirely different reference. It's right. So there was a problem with that. And so now this solves the problem of it used to be if you have some a damaged image and you maybe do a manual region selection to fix the alignment. Now you've still got to fix the next one after it because that image was used as its reference.
Got it, right. But now you don't have to. Now
you don't have to. And what you were actually trying to do when that would happen is you're really just you're no longer trying to optimize the alignment. You're trying to just get rid of that drift effect. But now we're not even thinking about that. And if you've got all your alignments good when you go to generate the ZAR, you never even have to see the drift. You never have to see this really. Yeah, we
don't care about the drift. We only care if it distorts the images as you go.
Yes.
Right.
And that's something that you decide later after you have each pair aligned as as perfectly as it can be.
Yes.
And it will be even better when you can remove the artifacts. But that's in
Yes.
next generation.
Yes,
Can't do that yet.
exactly.
Not this version. So
So in a sense, this is how we should have been doing things all along, I think.
Well, now you are.
Yeah, now we have it.
yeah, and this kind of had a snowballing effect with another it's taken a little bit to push this out to you guys, and I've been saying it's a week away for maybe 4 weeks, 5 weeks straight.
More like 3 months.
And really it's because of the snowball effect of if I'm being honest, the snowball effect of using these GIFs. This was a really, so that's what these are. These are just animated GIFs, and it's configurable how large you want these. And what's crazy is we can see from these like how good that alignment is. Like we've got what we need to see how good that alignment is. Do you know what size these are? Like, do you want to guess what size you think these are?
They look like maybe
Not what size they are in the window, because they might
Yeah.
have been like scaled. You know what I mean?
They
But
might
like
be 512 by 512 or something.
these are actually just 256 by 256.
Okay.
256 by 256 pixels. They're so small. Like, I mean, if these were at their true size, they'd be like that. So that's what I'm trying to say. That they've been, and so this is configurable in the interface. How small do you want these? But the point is, you get these. They're always going to be the same size, no matter what scale you're working at. So this is where you get the linear scaling with like the linear storage. Sorry, the storage. The storage complexity is linear.
Mm-hmm.
So
until you're ready to really make the czar.
But it still is, because
And
that's now more like an export.
Yeah.
When you export your TIFFs and your czar, and maybe I haven't implemented this yet, but I'm thinking of it more like, I'm starting to think of the czar as more of like something that you export. Like if you're using movie making software, you import your clips, which are like our images, and then you've got a library in the application of your video clips that you're assembling into a movie or something. And then when you get to the end, you export to MP4 or whatever, and that's sort of like exporting your alignment to czar. And that can be, so that doesn't have to be in the alignment directory. Right now it is, but moving that out of the alignment directory would mean that your alignments are only a few megabytes in size. All you've got is small files. Everything's been scaled down. There's nothing that's full scale in there. So right now you have that until you generate the czar, right? But you can just move that out, regenerate it later, and you can move your alignments around as just like a little 1 megabyte file, not a many gigabytes file. So so this is like a visualization of what I'm at, of this of the fact that we no longer we are no longer thinking in terms of like a project. Think of it as a series and an alignment, and these are actually named the way these are. Okay, so you import your images to create a series, and that's given an extension on that directory that's a dot series. So all of your series are going to end in dot series, and then all of your alignments end in dot alignment. So it's a long extension, but whenever you see that extension, you know exactly what it is.
I told Joel he can't use .ser for it, right?
Yeah, but why wouldn't you use images? .images.
If you like that better, now would be a good time.
I do, because we distinguish a series to us is the images and the traces.
Okay, I'll change that.
And now you're talking about a third component, which is an alignment. So you have the images, alignment, and traces. And then you're going to have another thing called, the 3D objects. So I'm not. I mean, series is series is the Uber name. I mean, it's the all-embracing name. So if you put images here, because now you're importing images. They happen to be a set of serial section images, But any images could be imported that you want to align. They could be something else, right?
But an important point here is that this is a stack of images that's been converted into ZAR for use in alignEM-SWiFT or any or even any neuroglancer that you wanted to view it with. It's not the raw images.
Doesn't matter. It ends up being, they're still images. They're ZAR images.
Sure.
Yeah.
TIFFs, they're ZARs, they're JPEGs, they're whatever they are, but they're images. They're not representations of an image like traces or 3D
That's true.
objects or something else. So
Yeah.
it's the images component of a series. It's not the series itself. The series itself has images,
Right.
traces, 3D objects, quantification.
Sure, they're images, but they've been transformed into a form suitable for use in alignEM-SWiFT and probably for other things too. So I just are worried about people using the word images in a generic way, whereas here we mean it in a specific way. Right? This is not just a folder with images.
Well, it starts as a folder with images.
Yeah, it starts as a separate folder of images.
And then it gets transformed and blah, blah, blah. But I mean,
And they get transformed into here.
Even though all the way down at the very bottom, it still comes out as images. At this point, those are images. They go through a bunch of different format changes, but they are still the images that are in that component.
That's true. That's true. But if you had just a folder of only images that haven't been transformed in this way and called them images and tried to point alignEM-SWiFT at them saying, here's my images that I want to do an alignment on, it wouldn't work.
Well, that's fine. I mean, but
Okay.
it's still the images component of our work. It's not
Sure.
the overall series component.
That's true. That's true.
So the images component should have the name images. You can put some constraints at the top of it that says this is the format they have to be in, or you have to do something to them. But when you first bring them in, they're going to just be TIFFs, and then you're going to do something to them.
Yes. So, and this is really up to you. What I've tried to do is give you guys the controls that you need to store your data where you want to store it, and to give you guys to provide you guys with a tool that is able to work with however you like, whatever your maybe a certain person in the lab uploads the image, like maybe you guys all upload your dot images, create your dot images, these directories that contain all the images and converted and everything. Maybe that's a certain place on the file system, and then what you do is whatever that place on the file system is, this is what you get when you launch the application.
Right. I just think it would be confusing based on all the history of using the word series and images differently from that. So I think if you just change it to images, it will not be confusing.
Yeah, that's what we'll do. So if you click set content sources right here, what you get is you have four text entry fields here. You have the series root, the series search paths, the alignments root, and the alignments search paths. So the series root is where your
call this now the image root, right?
Which will now be the image, but for the rest of this
demo, that's fine. I'm just interpreting that this is the thing.
Yes.
Yeah, that's where it would be changed to image root.
But for the rest of this presentation, I will still use series.
Okay, yeah, just so you can use it.
Yeah. So the series root, this is where if you create a new series, which you do by selecting this plus button right here, and I'll demonstrate that. What you do is you just give it a name right here, like demo series or whatever, and then it would be demo series dot series or dot images. And where would this be created? It would be created right here in your series root. That's what this means, the series root. Same thing with the alignments root. This is where when you create a new alignment of a series. So in here, you'll see a list of all of your series. And so, yeah, when you create a new alignment and you give it a name, that's going to go right here in the alignment root. And then the series search paths. This is a list of paths that you can put in here where alignEM-SWiFT will search for series, and it will be able to recognize an alignEM-SWiFT series. And same thing with the alignments. So if one person in the lab stores all of their series or their alignments in a certain location and they wanted to share those with somebody, it's as simple as giving that person the path, pop it in here, and then just say okay, and then refreshing. So and then refreshing, and that will reload these. With any series that are found in any of these search paths, right? Okay, and then
Hey, Joel,
yes, yeah.
would this be a problem if the permissions weren't correct?
So yeah, you guys are going to want to put into your good question, into your bash RC.
Because I think I have that already, but just in general for,
I love it.
you know.
Yeah. So you're going to need that in your bash RC. I think it's a ulimit command, right?
UMask.
When I if there's time, I'll log on to tag. Well, I'm already logged on, and yeah, I'm already logged on. So actually, I'll just show you like this.
It's by UMask. It'll show you what it is.
I want to show them what they need to have in there.
Yeah. So right now it says 007. It says it
Yeah,
right
UMask 007. That's all you got to put into your bash RC file. And we can help you with that. But I think you guys all have it.
But I
we
think
did
that's
this
the
together.
default one. Maybe that's the right one to
I
put.
think it,
Okay.
it is.
Okay.
I think that's right.
Okay.
You guys can check if that's what you have. I'm pretty sure that's correct.
So if you go to the command line,
Yeah.
go, and say touch food, and then say ls-al food, then we'll see. So
Yeah.
that makes it read writable by you
the
and
group.
your group people, but
We're all in the same.
but invisible to anybody else.
Yeah. So you can see what groups you're in by typing ID, and I believe we're all in the same groups who checked this.
Yeah.
There's at least one group that we're mutually a part of.
Yeah, I think
So
that's right.
okay. So back to might as well just run it on TAC actually.
Yeah.
Okay, so yeah, so is there any questions about the set content sources? Because this is what I mean. Like this gives you guys the power to store your data where you want to store it, whatever works for your routines or whatever pipelines you guys want to set up.
I don't necessarily want you to answer this question with a long answer, but is the short answer that in order to get stuff over to TAC, command line needs to be used? Or can you use 3dm.org to put stuff there?
These paths can be places on the workbench.
Other way around. Can you start at the workbench and go and grab a bunch of files and put them someplace?
That's a James question.
Yeah, you can, I mean, you can upload files using the workbench, but there is a size limit using the the web-based interface.
And do we have a wiki on how to do this sequential set of instructions on how to do this yet? So suppose I have not done this, Ashley. Where do you need to do it? Is there a place where the sequences of what to do to get your images there before you want to get started?
Yes, so there's currently a way on the wiki that uses WinSCP and like the PuTTY terminal in that, but then I and a lot of us use just the terminal and SSH through that, so I can show you those different ways. But it's also on the wiki.
Also, yeah, that's important. Not that I'm going to do it because I've become less and less the person who gets to do this stuff anymore. I'm more of a grant gerbil, but hopefully I'll get back to doing some stuff like this.
Okay, so moving along. Also, I added this timer here. I thought that might help you guys because there's sometimes your sessions die while something is happening, and that's hard to recover from. So this should help you like keep track. My thinking behind it was just that it'll help you guys keep track of your session, how long your session.
Also, I'm so sorry to interrupt again. I don't
Okay.
know if you mentioned this. Is best practice still using Scratch?
For now, that's what always works.
Okay.
And we can test this right now. But I have had success with having images on Corral and creating a project on Corral or not, like creating an alignment of that series, or like, yeah, so creating a series from those raw images and like doing all of this on Corral. I've been able to do that.
Okay.
With too much, it's a little slower, but not a lot slower. So,
Sure.
and you guys can try and see what,
And
and let me know, how it
And-
goes for you guys. But you can always use Scratch. You can always copy your images to Scratch and be fine.
but the new development over just the last couple days of mainly not generating the czar every time you do an align,
Should make it faster.
what should make it way better, even
Yes.
if you're not on Scratch.
Yes, and also since the alignment projects are so small now, it's not a huge deal, and you can also move them around now.
That was also my main thing. I don't mind if it's on
Yeah.
Scratch as long as I can now place them as I please. So
Yeah.
Yes.
I'm okay with any of those outcomes.
And
so that's another great reason for having this system with the series roots and the search paths, or the search paths really, because each alignment that you create. Sorry, okay. When you create a series, that gets a universal unique identifier assigned to it, which is in its metadata. And then when you create an alignment of that series, then it's aware of the UUID of the series that it belongs to. And so the alignment in the series, those can be moved anywhere in the file system. And as long as they're somewhere in a search path that's listed here, then that's fine. They can be moved around after the fact, or whatever. And each alignment is still going to know what series it belongs to, as long as they can find the series.
Will it prompt be like, hey, I can't find it, or it just won't work if it's
I'll make
out
it.
of range?
Yeah,
if
for
that makes
now,
sense?
it just won't work.
Okay. Maybe it could just even a pop-up say this doesn't work, even if it's just it can't find it, maybe like, because sometimes I'll open something,
Yeah.
I'm like, oh, it's broken and I don't know what broke it.
Totally.
So
Yeah.
I'm not sure if you're able to add those those error messages or what have you.
Yeah, that's on my to-do list. So thank you.
Thank you.
But the other thing that makes it faster is that the GIF images or the thumbnail images that are used for just a quick look and see of what you have in the user interface are done on small thumbnails. And when you do an alignment and don't make the czar, the alignment is actually being done on those thumbnails. It's using the original full-scale image for whatever scale you're at to do the alignment, but the result is applied to the thumbnails. So that is so fast to do that probably doing it elsewhere, outside of Scratch might still work okay.
Yeah.
And this is a new feature that Joel added in just the last couple of days. So it remains to be seen how effective a fix this is for that problem. But I think it could be effective.
Yes. Yeah. And so, yeah, excited to have you guys maybe give this a spin and let me know how it goes. Yeah. So
I think right now you wouldn't be able to use the new alignEM-SWiFT to open a previous project.
no, but I've promised Harris Lab that I will make a tool to do that, to convert. But yeah, like I said,
But we haven't done that yet.
The data model's been redesigned. It's completely different. And I needed to get all of these changes out. Like it's easiest to get all of it, like to if I'm going to be changing the data model, rather than change it iteratively over the course of different versions of this, I just needed to do it. It had to happen all at once. Same with changing the project structure. So that's all behind us now. And for that, if you guys have projects from the old version of alignEM-SWiFT, which so I promised to make you guys a tool that will convert those. It's going to be a separate tool though.
So Joel, I think it would be worthwhile for Ashley and Wei Ling and I guess Lindsay are the three people who have done alignments. Has anybody else done alignments on real data? Andrea.
And Andrea.
Andrea, you did a bunch, but Andrea, you're done, right? Or did you not get it to 1x?
I was able to get the first two animals, most of those to 1x, and then for the third animal, I think that was a little bit more variable. Most of those I think were scale 6. But then I was able to do enough like manual alignments and PyReconstruct that was fine for me.
So I guess conversions, because she did like 36 series, Andrea did, right?
Or 24.
24, some large number. So and we're going to share that data, Joel. So I guess it's worth making a conversion for that. I was thinking if it was just the test ones, you just redo them, but it's worth making the conversion because Andrea did so much work in the old version, and we want to be able to share. That's for the next dentate paper that has all the different layers and stuff in it. We want to be able to share all aspects of the data, but if the tool is no longer really useful, you don't really want to share something that can't be worked with anymore. So I think that therefore that conversion is a necessary step.
Yes, we'll work with you guys on that. Okay, so
And let's talk about the conversion just for 1 second. So I think the way the converter would work is it would convert the JSON of the project into the new format. And then what you would need to do is probably regenerate the alignment, because the organization of the files that are generated is different. And I think it would be easier just to regenerate rather than move all those files around. I don't know. We'll see in the process of making the conversion tool how hard or easy it is to just move the files around to their new places or regenerate. But the regeneration would just mean clicking a button saying go, right? You don't have to redo any manual work that you did. That's all in the data model.
Right.
Right. In the
well, Andrew, maybe I'll put that on your to-do list and let Ashley and Wei Ling and Lindsay benefit from that conversion. Could be exactly the same thing for theirs, but then you guys could start your next series with this new version and start testing it. How do you feel about that, Ashley and Wei Ling and Lindsay?
That sounds good to me. Unless something's really dire where I have to get from scale 6 to 1, I'll just redo it if it's the easier, maybe less time consuming series. Otherwise I can wait.
Okay.
Yeah, that works for me too. I really only did like aligned a series if I absolutely had to, and then it's not perfect anyway. And I just figured I kind of was already planning that I would just redo it and apply a new alignment in PyReconstruct.
Yep. The nice thing about PyReconstruct now is you can start working on tracing, and then you do a new alignment. You just bring in the new alignment, and all your traces, drop down menu, 1 button, all your traces now get snatched to the new alignment. So it's not that you have to go back in and do any more.
Yeah, and if you've been, and if the alignments had come from a scale 6, you know, the difference between the traces, or the difference between the affine and the scale 6 and the scale 1 will be just small changes to the matrix, to the transformation matrix, which will only move the traces by small amounts. So it should be okay.
Well,
so do I need to keep all the project files inside that SWiFT folder, or just the JSON file and the ZARs? And
For the conversion, you mean?
yeah,
So-
because I saved all the like SwiftIR like JSON files so I could apply it in PyReconstruct, but all the like project files with like the log files and all that are still sitting in Scratch, and I haven't touched those in a while. So I don't know. Do I need to keep touching them so they don't disappear, or is it enough just to have the SwiftIR file?
Did you say on Scratch?
Yeah, right now they're sitting in Scratch, but I guess in general, like for this conversion process, would you need the original and like entire project directory, or can you just like have the images and maybe recreate the ZARs and then have the JSON SwiftIR file?
I would definitely need the project file and the. I think I would need everything. I think I need
Everything? Okay.
yeah. But the main thing is the .SwiftIR file.
But
Um,
if something happens to the project files, like I need those project files, right?
So we might be able to do the following.
Like they say they
Yeah.
still exist, but because they're sitting in Scratch, I just need to know that I need to remember to like keep either move them to work or like keep accessing them. Otherwise they'll get deleted.
What do you think, James? To keep, while we figure this out, how to do this conversion. If Andrea keeps her files on Scratch, how often does she need to kind of touch them to keep them from being reaped and recycled?
Yeah, officially it's every 2 weeks, and you have to be careful about like actually using the command touch,
Okay.
actual command for those who don't know. Because they
Okay.
don't want you to just go around like touching the
Yeah,
file
yeah.
to like reset that.
Right. Okay. I was wondering about that. Yeah.
So I need to like physically open the file and then close it. Is that enough of a like
yeah, that touches it.
okay. Okay.
But what about putting them someplace they won't get thrown away, James?
Yeah, so work, they'll be safe. Corral, they'll be safe.
I would
Just move them off of Scratch.
Yeah.
yeah, if it's really important to you, I would save those project files that are just like a megabyte, at least save those. That's got all the data. So
Oh, just the project files? Okay.
yeah, I mean the data's all there. So that's the most important
The
thing.
files in the SwiftIR file and the JSON files.
Yeah, the JSON file, which has the extension .SwiftIR.
I see. Okay. Yeah, Andrea, I would, rather than wasting your time trying to remember, it's like turning the water on the swimming pool and then have to remember to go turn it off so it doesn't overflow. That never happens. I always overflow the pool.
Yeah.
I'm not sitting there touching the hose. I overfill the pool. So I suggest that you move it to a safe place.
Okay.
Since they think that they might need them in order to create the conversion.
Yeah.
Okay.
Well,
Yeah,
we'll
I can do that sooner rather than
yeah,
later.
we'll experiment with a couple things. Like one, what if all we have is your original stack of images that you started with even before you imported them into a
Sorry.
project? Yeah. What if we had just those and your SwiftIR file?
Yes.
Those two things alone should be enough to recreate everything.
They
Okay.
should.
Do you
that-
need
that
me
would
to
be my-
send? Do you
Let's
need me
say-
to send any like SwiftIR, or I guess you have enough old SwiftIR files to be able to test that.
We can meet about this specifically and separately.
Okay.
Another
Yeah.
time.
Yeah.
Yeah, I think it's an important thing, and having somebody who really is going to want to use it is the one to be in charge of testing it at this point. So I think having Andrea work with you, if you don't mind, Andrea, I'd appreciate that. It's critical for your material anyway.
Okay.
And of course, you would never throw away your original images, right? So that's kind of a no-brainer. And the SwiftIR file is where the work, all the work you did is really encapsulated.
Yeah.
In a regeneratable way.
Yeah, I think the tool will probably only need that, and then just to know where the source images are, as long as they're somewhere. and they're the same.
Yeah.
So like exactly the same, like the same number, like no images have been removed from the series and stuff. As long as the series, the raw images have not changed. That's important too.
They haven't.
Okay.
Yeah.
They shouldn't.
They were created 15 years ago. They haven't changed in 15 years.
Okay, so I suspected that this might happen. I was thinking this might need to be a 2-part thing. Kristen, what do you think about that?
Yeah, I think we're at a point where people have other things on their schedule for the day. And I think the thing to do, actually, Joel, rather than trying to demonstrate this to the whole group, it sounds to me like this was a great thing to have as a must do by October 12th. I think releasing it to Ashley, Wei Ling, and Lindsay and Andrea so they can begin using it this week and next week. And then, in the alignEM-SWiFT users group, solve problems. I mean,
Okay.
I'm happy for you to do a quick demo if you want to, but I'm convinced that you've made enough progress that you should just go for it. That's exactly what this meeting's for. Check mark. Mama K says go.
Awesome. Cool.
And let's get that out there. And then once you get the conversion working for Andrea's stuff, I would say then it seems to me there's 2 big tasks for alignEM-SWiFT. One is implementing the triangulation, the elastic alignment component. But I would say for our data, I would give higher priority to being able to cut out the flaws. I would do that first because our data don't have much elastic distortion.
And
Since we're your team. Yeah, Tom.
yeah, so when we discussed this with Art, we've had brief discussions about it before, kind of brief brainstorming sessions on it before. I think he and I both thought that the triangulation enables the cutting of flaws.
Okay.
And we would lay down the triangles in a way where the edges of certain triangles would follow along a fold or a tear, right? And then we would have an interface where the user would draw, lines
Right.
along the edges of the fold or the tear. And then we would lay down the triangle grid on top of that so that it follows along that line. And then mark those edges, those vertices along those edges, mark them as immovable. And then make a region on one side of that line and a region on the other side of the line where the other vertices within those regions are now movable. Or, if you're doing triangulation, or you just say, this is where we're going to do one alignment with one affine, and the other region is a different alignment with a different affine, 2 independent affines. Let's say, there's one fold that cuts the image in half or something. 2 independent affines at a minimum. And then if you're doing triangulation, then actually, separate triangulations. In the 2 regions, right? So the triangulation has a dual purpose here.
Okay.
Yeah.
I'm willing for you guys to figure it out with recognizing that the first priority is to get the ability to have separate domains for alignment.
Yeah.
Within the image.
And I think we could have.
They might need to both go at the same time, as you say, but you might not need to perfect the elasticity component of the alignment. You get the triangulation right, but then implementing the code that gives you the very best elasticity out in each domain, I think could be possibly put off as the second step. Do you see what I mean?
Yeah, I see what you mean.
You could divide the task into 2 parts.
Right.
Recognizing that flaw removal. Now, the other thing too is that you have to realize that some flaws you might not want to draw a line. You might want to draw, a lasso, because it's like a tear that's stretched part of it. And so then you're going to draw a lasso around it that won't be straight.
Sure. They
It's
could
still be a line though.
Yeah, or closed or open lines, and there could even be more than two regions.
Oh yeah, that's what I mean. It's going to have to be you're going to have to be able to say, ignore this part, ignore this part, ignore this part, even just that kind of thing. You might, in some cases, you might want to say, I'm creating two domains, you can line them both and everything in them is good, right? Like you had a perfect fold down the middle, or a perfect fold on part of it, right?
Yeah.
Then you have other parts where you just simply say, ignore this, ignore this, ignore this.
Right.
And it's so, I mean, I think this is going to be another, there's going to be a need to have some iterations on it. And so getting started, I think, is important.
Yeah. Now
Then we'll start looking at it together.
Yeah, and I think, if Art were here, he'd say, I think I'm understanding how Mir works enough. So Mir can work with triangulated regions, and so this is the reason why we would lay down the grid, or in fact it's arbitrary. It doesn't even Mir doesn't care what the shapes of the triangles are at all, right? It doesn't have to be a grid. It can be all kinds of crazy things. It doesn't matter. But the reason for doing it is so that you can have these regions that you've drawn that you want to mask out. You want to be able to triangulate up to the edge of those regions.
Got it. I get it.
At some resolution, and then what's so cool about Mir is it will then assemble the final image from the separate triangles that have been separately transformed into alignment, and you'll get one final image with everything aligned in it.
Yeah, that's exactly what you want. Exactly.
Yeah.
So Joel is showing us something here. What are you showing us, Joel?
Oh, I would just feel remiss if I didn't show you guys a little bit of the. I still think we should do a second meeting.
Okay.
Where we'll go.
And is this now? Are you showing us what the interface is going to look like?
This is how it works. This is what users will be using when they use this version of the application. Yeah, it's
so initially you showed us. You were showing us a different kind of screen. That was the series manager.
That was just, we hadn't even got past the series manager. Yeah, that was just the series.
Okay, so this is now the alignment screen.
Beautiful. Yeah, and there's just a lot of improvements. It's so like these X's on the SNR plot here indicate which indices are in sync with the ZAR. So in the ZAR metadata, I store like a hash of the swim settings used in the cumulative affine that produced that section in the series. And then so that's the caching. So then the first time you do this, generate the ZAR, which is I'm not sure what to call this button, the transform 3D. I for a minute had it called sync ZAR, like synchronize the ZAR. But the first time takes the longest because it's got to do all of them, still faster than it used to be. But then every time after that, since it's benefiting from this caching where it's not going to update any part of the ZAR where the cumulative hasn't changed. So then these X's will all go to green dots. And then if something changes in the cumulative halfway through the series, then you'll see that only you only get X's on the SNR plot for that point in the series and onwards, because of the way the cumulative builds opposed to the stack.
So, up there you say series manager, but maybe you want to call it the alignment manager.
Sure.
Because, right, you don't want to call it the image manager. This is really just, you're managing your whole alignment in that, right?
Sure, I like that.
But on this tab, I would call it the alignment manager. And then, the first thing you have to do is go find the original images. You have to go through all this image transformation, et cetera, et cetera. And then the second tab, you now are calling it demo, but would it normally say up in there what?
That's the name. That's the name of the alignment. So there's
Alignment.
a directory on your file system somewhere called demo.alignment. I just don't put the extension in the tab.
I got it. Okay, so that's excellent. Mhm.
Yeah, that's the name of the project.
Yeah.
He just happened to call it demo.
So what I've clicked here is the transform 3D button, and that's just finishing here. And again, it's just the first time takes the longest, but still faster than it used to be. And this is the thing that you're not necessarily always going to be doing that often, because and if there's one thing to show you, it's that you get this GIF here. And then so now we can still view the cumulative. We also generate a GIF of the cumulative versus the aligned image that comes before it. So this is what you used to always have. And then now we expect users to primarily be using this to optimize their alignments. And you only get this when you synchronize the ZAR. But if you do that at the very end, then presumably you've optimized all your alignments, got the SNRs up, and then you'll see that you'll already be on the other side of weeding out the drift. So you never have to see the ugly drift.
So when you say so the flicker is just flickering between a pair, is that also true for the cumulative, or can you roll through them all, or do you just roll through them all by pulling the slide bar?
Yeah, and then this will go. Yeah. Yeah, you can use arrow keys. You can use the slide bar. You can scroll in here in NeuralGlancer, and then that will scroll NeuralGlancer too.
And is the reference section always the previous section?
No, it's the previous non-skipped section.
That's what I mean. Yeah.
Yeah.
Or we're using include exclude terminology now.
Yeah.
For skip. So yeah, if it's excluded, then it will be aligning to the one before it.
I got it.
So yeah. And then you see all these.
Do you feel ready to take this on and test it?
What's that?
Oh, and now the green dots show you.
That means that the
Oh,
ZAR
yeah.
is generated, and then if the cumulative changes halfway through the series, then there'll be X's from that point onwards. And now we can go over to the view alignment, and we can actually view our three-dimensional ZAR here. And let's refresh. Yeah. So you can always refresh, because again, this is a web server basically. This NeuralGlancer is a web app that's embedded into the application. So refresh is useful, just like it is in an ordinary browser.
So I want to point out that the upper left and right images are the view from the side.
Right.
And they look almost as good as the top view.
Yep. They're the only thing that they're not is isotropic. So that's why they're not perfect.
Yeah. But at this
but the resolution is different.
But at this resolution, it's pretty darn near isotropic.
Yep. Well, I mean, it's not, because look at the individual pixels are much larger in the top two images than the bottom right.
Almost. I said almost.
That can really help us to see whether we need to reshoot some really out of the alignment.
Yes.
Yeah. Extremely useful. Really cool, guys. My hat's off to both of you.
Joel gets all the credit.
No way.
He had to put up with me saying, "Why isn't it done yet? Why isn't it done yet?"
Well, that's very. It's now the lower right hand corner one now looks like a heartbeat instead of what is it?
Yeah, I'm not.
Something didn't update.
This one right here, I think it was. Did anybody see what index that was?
You should have looked at it before.
Yeah, I should have.
It's in the movie. I mean, in the recording of our session today.
Yeah.
Yeah.
We can go back and look and see what image that was before you move the slider.
Whatever it is, I suspect that it's
It just
something
didn't
just
update.
bugging, like being buggy.
Yeah, it just didn't update, or wasn't showing the right pair somehow until you did a refresh, and then it was happy.
Now, any
Yeah,
SNR that's above 10, you consider to be good enough?
As a general rule, would you say?
So these things are variable, but if it's above 10, yeah, it's almost certainly solid. Could possibly be made better. And what you really want to look for are discontinuities in the graph, because that means why is that one so much lower than its neighbors, right? And so even though it might be good enough, it's an outlier on the graph. You should look at it.
Yeah, of course.
And decide, yeah, it's good enough. Or, you know what, that could be made better. Or there's a defect, and that's why it's not as good. The alignment is good, but there's a defect, and that defect is influencing the value of the SNR, but not necessarily the absolute goodness of the alignment.
And Rachel, you should go after that mitochondrion up in the yellow corner. Did you see the one that has the extended Christie?
Oh, I didn't catch that. Sorry, could you show it
It
again?
jumps right out of you. If you back up a little bit, you'll see it.
Oh, do what? Again?
Just go back down a little bit in the section series. There's a mitochondrion that looks like one of Monil's Shaw's mitochondria that's undergoing all kinds of local change. It's perfectly healthy. I mean, look, in the old days we would have called it an artifact. Now we know it's a functional. There. Oops, you went too far.
Which one was it?
He zipped by it.
Yeah,
There.
you have better eyes
Oh, there's
than me.
two examples.
Oh,
There, right there.
in the blue quadrant?
The yellow quadrant up in the upper right
Yellow
hand
quadrant.
corner.
Right hand corner.
Okay, so the right hand
Oh, I see.
just a little bit down, you can see some opening in the mitochondria, but then there's another one in the middle. If you scroll through this, you'll see that there's these mitochondria. There, stop. Oops. You were there. There. Stop there. See the one right now in the middle of the yellow?
Middle of the yellow.
Upper right hand corner. There's a mitochondrion and a dendrite that has a big white spot in it. But as he scrolls through it, it becomes a little skinny guy again on either side.
Oh, that white void, huh?
Oh, yes.
It's not
Okay,
really
so
a
I see.
void. It looks exactly like what Monil sees in some of the
Oh,
mitochondria that
okay.
have become activated.
Wow. Okay. Yeah, I haven't looked too much into that sort of thing. You said Monil?
Monil Shaw is one of our students from the course, so just watch it. See as he goes down, becomes totally normal again, connected. So it'd be interesting to know whether or not that's a spot where it's splitting or bending or actually distending to.
Yeah.
I'm wanting to map the mitochondria for their activity because he's been showing really distinct changes. He's with
98. So go
Vidya Rama, whatever her
view
last name
alignment.
is.
Since
Yeah,
you
the
did the job,
mitochondria
let's go to
people
view
in
alignment on
Florida
this.
at St. Augustine's that are
So
part of our
get rid of
group.
those
Oh, okay. Yeah.
Yeah. So he's been studying them
and zoom in
individual
on
mitochondria.
where that mitochondria that she was talking. Oh, but it's off the edge of the. Yeah, unfortunately, when we go to view alignment, that particular mitochondrion is off the edge of the bounding box.
Well,
I wanted to see what it looked like.
Really?
It would have been in the upper right-hand corner of the bottom, or off the right-hand side of the bottom image. Get rid of these two so that we're looking at just that one.
Oh, yeah.
I'm sorry, I'm distracting us. I'll come back to this.
So that mitochondrion is off the right edge. No,
Sorry.
You just go back to the alignment. We can find what section it was in.
it's on section 98. This is section 98. No, this is not section 98. This is 109. Go back to 98. But that mitochondrion is off the right edge of the image.
Off the right. Oh, it exists, but it's not part of the.
Right. It got
Field
cropped. It got cropped by the image bounding box, which isn't big enough.
Oh.
Right? Because we didn't say make a bounding rectangle around the whole thing. So it's being cropped.
Why didn't you make a bounding rectangle around
Because we didn't yet.
Oh.
You would have to click that button and redo the alignment.
I see. Oh, I see what you mean, because with time, that part of the field is no longer in the volume. And so you have to
Yeah.
readjust when you do the cumulative. There it is, right?
So the output settings where you would do that are right here under output settings. It's kind of a funky little way to have them. I might move them up here actually, but the output settings are how if you turned on the bounding box and regenerated, then
Then you would keep it
and it
in.
would fit. You'd keep it. You don't lose anything if you turn the bounding box on.
Got it.
So yeah.
All right. I think we're half an hour past our designated time. We should probably let people are drifting off that need to drift off. Good work. Good work.